Hello everyone, we've got a tricky parametric integration question here with quite a lot going on. So let's have a look. It says figure 4 shows a sketch of part of the curve C with parametric equations x is equal to 3 theta sine theta and y is equal to sec cubed theta in the interval pi over 2 to 0. The point P, K8 lies on C where K is a constant. Find the exact value of K. So the way we're going to start this is you'll notice that we're given all the information that we need about the y coordinate. We're told that the y coordinate is 8, and that's going to be our key to unlocking the value of theta at that point. So we're going to write that 8 is equal to sec cubed theta. So we're then going to cube root both sides. So 2 is equal to sec theta. We'll then take the reciprocal of both sides. So 1 over sec is going to be cos. And that gives us that cos theta is equal to 1/2. So let's have a look at that. So we've got two solutions in the range 0 to 2 pi for cos theta is equal to 1/2. And when we do inverse cos of 1/2, we find out that this principal value, the one that our calculator gives us, is pi over 3. We don't need to worry about working out that one because we only need the value that is less than pi over 2. Okay, so we want the value that's less than this. So therefore, the theta value that we require is theta is pi over 3. So we take that value of theta and sub that now into our x equation in order to find out what k is. So we're going to have 3 times by theta, which is pi over 3, times by sine of theta, which is sine of pi over 3. So we're going to have x is equal to 3 times by pi over 3 times by root 3 over 2. And that gives us, the 3's cancel, we get 3, so we get rather root 3 times by pi all over 2. So root 3 times by pi all over 2, and that is our k. So that's part A done of that question. We took the y coordinate, cube rooted it, solved for theta, took that value of theta and subbed it into the x equation, and the value, the x equation was our k. Okay, what's next in the question? So it says, the finite region R shown shaded in figure 4 is bound by the curve C, the y-axis, the x-axis, and the line with the equation x is equal to k. Show that the area of R can be expressed in that form. So this is going to be parametric integration. So we're going to be integrating y dx by d theta by d theta. So y dx by d theta by d theta is our formula for our parametric integration. So let's have a little think about that. So our y, that's nice, that is just sec cubed. So that is sec cubed theta. And then dx by d theta, our x is theta times by sine theta. So if we're going to differentiate that, that's going to use, we're going to need to use the product rule. So I'm going to call that u, I'm going to call that v, and my product rule is going to be u dash v add u v dashed. So my u dashed is going to be 1, my v is going to be sine theta, my u is going to be theta, and my v dashed is going to be cos theta. So my dx by d theta, when I differentiate it, is going to be sine theta plus theta cos theta. So I've differentiated my x there. Okay, so I get sine theta plus theta cos theta. Okay, that's great. And we've got a 3 in front of that whole thing there. Okay, so we're going to have a 3 in front of that whole thing there. It's going to have a 3 in front of that. So our dx by d theta is going to be 3 sine theta plus 3 lots of theta cos theta. Okay, so let's put that in there now. So that is going to be 3 sine theta plus 3 theta cos theta d theta. Okay, it's looking a little bit squashed there, but let's move it over here a bit and expand the bracket. So I've now got that this is going to be the integral of sec cubed theta times by 3 sine theta plus sec cubed theta times by 3 theta cos theta d theta. I'm going to expand that whole thing. And now let's take a moment and see what we're aiming for. We're aiming for sec squared. Okay. Well, let's have a think about that. Yes, we're aiming for sec squared and we're aiming for tan theta sec squared theta. Well, sec squared can be thought of as 1 over cos. So I could think about this bit as sec squared theta times by 3 sine theta over cos theta, because sec is 1 over cos. So I've just borrowed one of those coses there, which is extremely useful because that's going to give me a tan. So I'm going to be able to get a tan from that. Okay, so that is going to go to here. That is going to go to tan theta sec squared theta there. So that's one of the terms that we're after. So that's super useful. Let's look at this next one. Sec cubed times by 3 theta cos theta. Right, let's think about what's going to happen there. And we're aiming for that to go to theta sec squared. Theta sec squared, yeah. Okay, again, sec here is 1 over cos. So we can basically think about this one as being sec squared theta times by 3 theta times by cos theta over cos theta. So I've reimagined one of the sec as think about it as 1 over cos. So that's just going to cancel with that. So I end up with now, there's a 3 there as well. I end up with 3 theta sec squared theta d theta. And you can see that we've got everything in the required format now. Okay, everything there is in that required format. We can take the 3 outside the front because it's common to both. And we end up with 3 lots of theta sec squared theta plus tan theta sec squared theta d theta. Okay, so we've got that in the required form now. The only thing we need to think about now are the limits, and the limits are between k and 0. We already found out that k earlier on was our root 3. Oh, let's think about this now. Actually, we've got to change our limits here, okay? Because you'll notice that the k value that we found is an x value, okay? But we're integrating with respect to theta. So we've got to basically change our limits to make them reflect the fact that we are integrating with respect to theta, okay? So let's have a think about what we're going to do there, what we're going to change those into. Well, let's have a think about those. So we're going to say that we've got limits here of, we know that we've got x here, and we know that we've got theta here. Well, we know that we've got x is equal to 0 at the left-hand side, and we know that our k from earlier was root 3 times by pi over 2, okay? And we've got to try and find out what the corresponding values of theta are at those points. Well, we know that when x is equal to root 3 pi over 2, that gives us a value of theta is pi over 3 at that value. And then over here at the left-hand side, we can see that when we have x is equal to 0, our theta is also going to equal 0 as well. Okay, so we've basically got our limits now are between pi over 3 and 0 there. Okay, that's good. Good. So now we're ready to begin to, let's just double check those limits. That seems sensible to me. So that's going to be 0 and pi over 3 for our limits. Okay, so that's part B done. We've basically found out what lambda, alpha, and beta are. Lambda is 3, alpha is 0, and beta is equal to pi. Now it's time to do the actual integration now in part C. Let's have a look at that. Okay, yep. Let's look at how we do that now. Okay, so first of all, so we've now got to integrate this expression. So we have got theta sec squared theta to integrate. Now that's going to need to be integrated using integration by parts. So we're going to say that u, if you remember that little acronym, u can be late. That's logarithms, algebra, trigonometry, exponentials. And we've got here algebra and we've got trigonometry. So basically the algebra trumps the trigonometry. So the theta is going to be the u. So u is going to be theta. So therefore u dashed is going to be 1. The v dashed is going to be sec squared theta. So therefore v is going to equal tan theta. So when we substitute into our integration by parts formula, we're going to have u times v minus the integral of v u dashed. And again, we're given that parts formula in the book, in the formula booklet. Our u times v is going to equal theta times by v, which is going to be tan theta, minus the integral of v, which is tan theta, times by u dash, which is 1 d theta. So it goes to theta tan theta, and the integral of tan is ln mod sec theta. That's given in the formula booklet. Okay, so you don't need to worry about that. So that's the integral of our theta sec squared theta. It goes to theta tan theta minus ln mod sec theta. And again, that's using some standard results from the formula booklet. We're given the integration by parts formula in the formula booklet, and we're also told that tan integrates into ln mod sec. Let's look at the next term now. So we've dealt with that one. The next term we've got to know how to differentiate is this one. I'll just write this down here. This is tan theta sec squared theta. Now this one looks to me like it could be chain rule in reverse, because if we think about an outer, an inner, and a derivative, my outer could be something to the power 1, my inner could be tan theta, and the derivative of my inner would be sec squared theta. So I would integrate the outer, divide by the derivative of the inner. So the tan would go to 1/2 tan squared theta, because I've raised the power by 1 and divided by the new power. And then I divide that by the derivative of the inner function. So the whole thing gets divided by sec squared. So that disappears. So I end up, when I integrate that, with that goes to 1/2 tan squared theta. Okay, so let's bring those results together now, because don't forget we've got a 3 in front of this whole thing. Let's just bring those two results together. So when we bring those two results together, we have got that our integral, let's write the whole thing what we had before, between 0 and pi over 3 of theta sec squared theta add tan theta sec squared theta d theta. We've just said that our theta sec squared theta goes to this result here. So that is going to go to theta tan theta minus ln mod sec theta. Okay, that's fine. And then we've said that using the chain rule backwards in reverse, this one just goes to 1/2 tan squared theta, 1/2 tan squared theta. We've got a 3 outside the front of this whole thing. And now that we've integrated it, we have to evaluate this whole thing between pi over 3 and 0. Okay, so that's looking good. So now it's just time to sub in our limits and see what we get for our areas. So let's just sub in our limits. My goodness, the mark scheme's kind of undecipherable in this one. It seems extremely complicated. So we're going to put in our pi over 3. So we're going to have pi over 3. And we'll have tan of pi over 3 there. Got a 3 outside this whole thing. So pi over 3 times by tan of pi over 3. Let's just see what tan of pi over 3 is. Tan of pi over 3 is root 3. So that's going to go to pi over 3 times by root 3 there. Okay, so we've got pi over 3 times root 3, and we've got a 3 outside that whole bracket. But I'll bring that 3 in a moment. So we've got 3 there. Then we've got learn mod sec. Okay, let's think about that. So sec of pi over 3 is going to be 1 over cos of pi over 3. So we need to do cos of pi over 3. Cos of pi over 3 is a half, and 1 over a half is 2. So that is going to be minus learn 2. So we've got minus learn 2 plus a half tan squared theta. So tan, oh yes, tan of pi over 3 is root 3, and the root 3 squared is going to be 3. So let's just write root 3 squared times a half. So that's going to go to 3 over 2. So that's our first bracket subbing in our pi over 3. What about the next term? When we sub in 0, so we're going to have 0 times tan theta will be 0. We're going to have learn mod sec. Now, sec of 0 is the same as 1 over cos of 0. Cos of 0 is 1. 1 over 1 is 1. So this is the same as learn of 1. And learn of 1 is 0. So that term goes to 0 as well. Okay, so sec of 0 is 1 over cos of 0. Cos of 0 is 1. Then 1 over 1 is 1. So sec of 0 is 1. And then learn of 1 is nothing. So that's why that term is 0 there. And then tan of 0 is 0. So we have another 0 there. Okay, perfect. Right, well, we're really getting there now. Find the exact value of r. There's loads of ways we can write this now. And I don't think they're particularly that fussy about how we write it. So we're going to have pi times by root 3 when we multiply that bracket out, minus 3 ln 2 plus 9 over 2. And we're not being asked to find it in a particular form. And, you know, any form is acceptable. So this form is entirely acceptable. And that's that question done. I thought that was quite a tricky question there with a lot going on. You know, lots and lots of potential problems there. I hope you found that helpful, and I'll see you in the next video.